And hello from Africa. Decided to come on a little safari, have a little adventure, and came across this pack of elephants here. I think they're cool. This one's looking a little angry, might charge me, but hopefully there's no lions here in the background. But I think I'm safe. Anyways, welcome to our last week of our remote learning and just new content here. So we got this week and then a couple days next week that will allow you to just wrap things up, finish things, and get caught up if you need to. And then hopefully your other classes are wrapping up as well. Can't say I'm happy to be done with things, but it is a bittersweet ending, I guess. Hopefully you will enjoy your summer, but I definitely miss just, at least I feel like I'm talking to you. Who knows who's watching these, but I'll definitely miss you guys. But let's go ahead, get to our riddles for this week. I'm running out of riddles. Imagine that. But first one here. What question can you never answer yes to? What question can you never answer yes to? Answer in 3, 2, 1. Question is, are you asleep yet? Because if you say yes, then you're not asleep, then you're lying. Get it? Anyways, next one. A man who was outside in the rain without an umbrella or a hat didn't get a single hair on his head wet. Why? Because he was bald. He didn't have any hair, so it couldn't get wet. Contrary to public belief, I am not bald. I have plenty of hair. I don't know why people say that I'm bald. Mr. Hicks is bald. I am not. Anyways, next one. Last riddle of the year. Man, lots of lasts. Anyways, where does today come before yesterday? Where does today come before yesterday? In the dictionary. Get it? Because T comes before Y. Gotcha. Anyways, okay. Again, hopefully you are keeping up with things, crossing that finish line with us, and finishing strong here. I know some of you guys, you're ready for summer, ready for this weird weather to not be so cold anymore. So that's why I came to Africa. It's nice and hot here. Okay. Anyways, getting to our last content here, finishing up our three-dimensional unit. So we're continuing with our volume, finishing up with our remaining shapes that we've talked about, and then we're good to go. Okay, so let's go ahead and jump over to our notes here, and we'll get this done. Okay, so our three-dimensional modeling in this week, 4 tasks. Okay, first one, identify the 3D object generated by rotations of 2D figures. So we'll talk about that very briefly, but then our goal really is to get into these 3. Determine the volume of cylinders, cones, and spheres. Okay, now that first point. Okay, in the previous 2 weeks, we've talked about 2-dimensional representations of our 3-dimensional objects. So we started off talking about surface area. Remember, that's if we take a 3D object, we're looking at the area of the faces. So that's a 2-dimensional representation. Okay. Then last week, we also talked about cross-section. So if we were to cut off a piece, what shape would we see? Again, that shape would be a 2-dimensional shape. So it's another 2-dimensional just representation of our shapes. Okay. Last 2-dimensional relationship that we're going to talk about here in this guy is what happens if I were to take this 2-dimensional, in this case, square, and rotate it about this line. Okay, so if I were to rotate really fast, what shape or what solid would I create, or what solid would I see? Okay, so that's what we're talking about here. So solids of revolution, because we're revolving around a line. So a solid figure that is obtained by rotating a plane figure or a 2-dimensional figure around an axis. So what that's saying is I'm taking this square and I'm rotating every single point around this line. So if you think about that, think about this as a revolving door, right? You're taking that door, you're rotating around and around. And if you rotate that fast enough, what would you see? Well, in this case, you would see a cylinder, okay? Because we have this square that you can see here. And if that rotates, you're going to create a cylinder. Now, that's something you would see. Or if this, imagine it left a trail, okay? Or like it's a 3D printer, right? You would end up with that cylinder. So our goal here is to say, okay, what solid or what 3D shape is created by rotating this 2D figure about this given line. So if I start here, I look at this triangle. This is a right triangle. I'm rotating around line L. So if that rotates really fast, okay, what would I see? Well, obviously I would have something over here, okay? I would have a rounded edge that goes around the bottom. And what is that? Well, that comes out to be a cone. Okay. If you've ever, as a kid, or if you've seen a kid, if you see a triangle flag on just like a stick and you spin that round and round, then you can kind of see that cone is created. Okay. What about here? So I have this half circle, so a semicircle. If I rotate about this line, what's going to be created? And I could really do this with a full circle, but I'm going to have the other side of the circle, and that's going to rotate around and around, right? And so that's going to create our sphere, a three-dimensional ball there. Okay. And a little trickier one here. What if I have a rectangle? Okay, well, we saw in that first example here, I took this square or a rectangle. It creates a cylinder, right? But the difference here is that rectangle is not on that line, right? So if I rotate this guy around, I'm going to get over here, but this guy is going to rotate here. So I'm going to have this shape. So how would you describe this? Well, I would describe this as a cylinder with a hole, right? So it's kind of like a toilet paper roll. So this would be a cylinder with a hole. Okay, so again, the main goal here is just to be able to visualize. This is actually kind of a calculus idea. So you do a lot of revolving. There's what we call disks in calculus. So it's actually kind of extending on our geometry and getting into some calculus ideas. So just keep that in mind if you move on and you ever take a calculus class. Okay. All right, but why are we talking about those? Well, if you notice here, all of these shapes, when we start to revolve and rotate around a line, what really is the basic shape that we're talking about? Well, down here, you see we have I'll use blue here, I have a circle. Right here, I rotate around this line, I have a circle. Here, I rotate around this line, I have a circle. Okay, so we end up with these shapes that deal with our circles, our cones, our spheres, our cylinders. So that's where we want to be able to find the volume. Last week we found the volume of our prisms and our pyramids. All right, those had rectangles and triangles. Here we want to find these our cylinders, our cones, and our spheres. Okay, so just to recap, our volume, it's the measure of the amount of space that's the solid encloses, or how much space is within our shape. Okay, so quick recap of last week: volume of prisms, volume of pyramids. So our prisms, the volume was the area of the base times the height. So remember, volume was big B times the H. And remember, the height is that distance or that length extended. So the distance between the bases. Okay, so just remember that, again, with these, when we started to get into these three-dimensional, the dimensions or the terminology, it's all different. So either height, width, length, they're all interchangeable. So don't let that confuse you. Okay, and then our pyramids, 1/3 the area of the base times that height, that perpendicular height. Okay, well, why did we want to recap? Well, if I look at our cylinders here, all right, well, a cylinder, remember when we first talked about cylinders, we grouped them with prisms, because a prism, remember, it had a base on the front or on the top, and then it had a congruent base on the other side. They were parallel to each other. Our prisms just dealt with our polygons, squares, rectangles, triangles, hexagons. Well, a cylinder, it's the same thing, right? Except our base here is just a circle. So I have this base on top, I have this base on bottom, and they're parallel to each other. So if you see that relationship, well, the volume of a cylinder is the same exact thing, still big B times H, okay, that distance between the two bases. Now, since cylinders are specific and they have those circles, then I could actually make this equation more specific. The area of the base, remember here, big B for a circle is just pi r squared. So I can make this as specific to a cylinder and say pi r squared times h. And that would be our volume for our cylinder. Okay. So let's go ahead and apply that here. So volume being pi r squared times h. Here it says Andrew wants to mail his brother a collection of marbles. He needs to calculate the volume of the mail tube before he buys it to ensure that it will hold all of the marbles. So I want to find the volume of this tube to the nearest tenth. Okay, so if I look at this picture, okay, it's a cylinder. So remember, when we talk about the base, we're talking the ends here. So the circles. Okay. Now with our cylinders, I don't really even need to worry about that because our volume or our equation is just pi r squared times h. Okay. In this case, volume. So I have pi. Our radius here is 1.25. I want to square that and then times h. Remember, h is the distance between your two bases. So in this case, 10. Oh, sorry. So I've got 10 here. Okay. Now, I ran across a couple people that were getting some wrong answers. Reason being, when you have this squared, let's change our color here to blue. That is only squaring this radius. That is not squaring anything else. So you need to make sure that you do that first. Okay. So I'm going to have 1.25. I square that, and I end up with 1.5625. So just showing you step by step, I have pi times 1.5625 and then times 10. Okay, now I could plop all this into my calculator. Now remember, if you do this on Alex has you approximate pi with 3.14. Okay, and for our purposes, that's totally fine. Usually when I calculate this, I just hit the pi button. So I'm going to do that now. I'm going to hit pi times my 1.5625 times 10, and I end up with 49.087. Now remember, to the nearest tenth. So if I were to round this, I would round up to 49.1. Now we're in inches, and since we're in volume, that is cubed. Okay. So there is our volume of that cylinder or that tube. All right. Next one, pyramids. Well, not pyramids, cones. But why am I grouping these together? Pyramids and cones. Well, if you notice, a pyramid, it just has a polygon as a base, but our sides come up to a point. Do you see that relationship between our pyramids and our cones? Right? It's essentially the same idea. So if our pyramids have a volume formula of 1/3 area of the base times the height, well, I could write that for our cones as well. 1/3 big B times H. Okay. Now again, a cone, the base down here is a specific kind of shape, right? It's our circles. So our big B again is pi r squared. So I could just plop that in. Our volume for our cone would be 1/3 pi r squared times the height. And that would be our volume formula. Okay. Now, again, keep in mind that height is always that perpendicular height. So sometimes they might give you the slant height. Just remember, this is the perpendicular height. Don't fall into that trap. Okay. All right. So let's go ahead and apply that formula. So here I have Rita serves shaved ice in paper cones. What is the volume of the paper cone? If you've ever been to Rita's, you have a cone-shaped vessel that they put the shaved ice into. So I want to use our volume formula, 1/3 pi r squared times h. Okay, so in this case, volume 1/3, I have pi, our radius here. So here, diameter is 10, so our radius is 5. I'm going to plop that in, 5 squared. And now I need h. Now, just like I explained on that last slide, the h is the perpendicular. So this is not h. Okay, h, and I'll change this color so it's easier to see, is that perpendicular height. So I need to find that h. Okay, so how do I do that? Well, if I look here, okay, drawing that in, I have a right triangle. Whenever I have a right triangle, you know I can apply Pythagorean theorem. Okay, so in this case, I'm going to have 5 squared plus h squared equals 15 squared, keeping in mind that 15 is the hypotenuse. Okay, so then I have 25 plus h squared equals 15 squared is a 225. I'm going to subtract that 25, so I end up with h squared is 200. And then I need to take the square root. So h is the square root of 200. Okay? I'm going to keep that exact for now. Reason why I want to keep that exact is if I round it at that point, well, then I know my final answer is going to be even further off. Okay? So now I have all these numbers. I, again, can just plop these in my calculator, just make sure this 5 squared is being calculated first. Same thing with the square root of 200. Those are all separate calculations. Okay, so then if I type this in, 1 divided by 3 times my pi, I'm going to use pi button in this case, times 5 squared times the square root of 200. That's going to end up with 370.24. This doesn't specify what to round to. I always default to 2 decimal places, so I'm good there. Cubic centimeters. Okay. Now, we could keep this in exact form. That gets a little messy again. Here, for our purposes, let's just plop this in our calculator. Boom, spit that out. Okay. So there is our cone. Last but not least here, let's talk about our spheres. Okay. Now, the derivation of a sphere, okay, just a little tidbit for those of you guys that are interested. How we come up with this is we can approximate this. And again, this comes down to more kind of a calculus idea, is we're going to break this down to infinitely small pyramids. Right? We could piece them all together and then it could create this sphere. But if I look at our pyramid formula, remember that is 1/3 area of the base times our height, which in this case, the height would be the radius of our sphere. Okay. I don't know why I have this. Ignore that. I just didn't erase. Sorry. Okay. But, so if I want to think about this guy, well then if I have infinitely many of these pyramids, if I then piece them together, right, I'm going to multiply by how many pyramids there are, right? Well, there's infinite amount. But what does that change? Well, that takes this area of the base and it creates the whole sphere. Right? Well, that would then be the surface area of the sphere. Okay, so if you think about the surface area formula, that was 4 pi r squared. So then if I take this guy and I multiply by 4 pi r squared, that's going to end up with our 4/3 pi r cubed. Again, it's not a complicated, but it takes a little thinking to get to this formula. So I'm just going to give it to you. 4/3 pi r cubed. If you want to look up how do you get from that pyramid to the sphere, by all means look that up or ask me to explain. I can do that further. Okay, but that is our formula. So 4/3 pi r cubed. Okay, so let's apply that. So here it says the Abuelita Chocolate Company, that's a real company in Mexico, by the way, wants to create bite-sized chocolates. If the diameter of each chocolate is 1.5 inches, find the volume of chocolate used to make a batch of 2,500 chocolates to the nearest hundredth. So I want to know how many pounds of chocolates, or what's the volume of chocolate I need. Okay, so if I want to find 2,500 chocolates, I first need to find 1. and then I can multiply that. Okay. So volume of one of these chocolates, remember, is 4/3 pi times my radius cubed. Well, if my diameter is 1.5, I need to cut that in half for 0.75 cubed. Okay. Now again, I have all those numbers, so I can just plop them into my calculator. I'm going to use the pi button in this case. I'm going to say 0.75. I'm going to raise that to the third power, and I end up with 1.767, and this would give me cubic, and we're in inches. Okay. Now again, keep in mind that is for just one chocolate. So then I want to find how much I need for 2,500 chocolates. So I'm going to take that 1.767 times 2,500, and that's going to give me 4,417 point, it says nearest hundredth, so 8.6, and that's cubic inches. And that's how much chocolate we need. Now, for a little fun fact here, I gave you, and I looked up, this is real, for milk chocolate, 1 cubic inch weighs 0.02 pounds. So if I want to know how many pounds of chocolate this is, because I think that gives us a little better number in our heads, I'm going to multiply this by, so 4417.86 times 0.02. That's going to give me 88 pounds of chocolate. Now that's a lot of chocolate. Huh. I wouldn't mind eating all that. Anyways, okay. So that just took us through a little story problem. I know last week I threw some story problems at you on that quick check. And some of you guys got a little caught up in, do I multiply, do I divide? So this takes you through a little bit of that. Okay. All right, so now that we know all of our shapes, we have prisms, we have pyramids, we have cones, we have spheres, we have our cylinders. Okay? Ultimately, again, you don't look out in the world and just see one shape. You see composite solids or composite shapes. So we put, in this case, we have a cone on top of a semisphere or a hemisphere. Okay? So I want to find the volume of this guy. So I'm going to break this into our two shapes. I have our cone. So our volume would be the volume of the cone plus 1/2 the volume of the sphere. Okay, so if I want to find the volume of the cone, remember that is 1/3 pi r squared times the height. Okay, and then I have 1/2 the volume of this sphere, which was, anybody remember? 4/3 pi r cubed. Okay. So once I have those formulas written out, I can, again, just plop stuff right in. So I have 1/3 pi times, in this case, our radius is 8. And our height of that cone is 17. That's not the slant height. That's just a perpendicular height. So we're good there. Okay, and then I have 1/2 times 4/3 pi, and in this case, 8 cubed. Okay. All right, now again, I could plop this stuff into my calculator. So 1/3 times pi times 8 squared times 17. If I calculate that out, it comes out to be 1139.35. And then if I calculate this guy, I have 1/2 times 4/3 times pi times 8 cubed. Remember, cube that 8 first. Okay, follow your order of operations, and then I can end up with 1072.33. I add those together, and I end up with 2,211.68 to the nearest hundredth. We're in millimeters, and we're volume, so that is cubed. Okay. And there is how we find our composite solids. Okay. To me, finding the volume of a composite solid is much easier than finding the surface area of a composite solid. So if you struggled with that a couple weeks ago, hopefully this one's a little easier. You're just finding the volume of each, plopping them together, and boom, you're done. Okay. All right, so to sum things up here, all right, we have the volumes of our cylinders. That's pi r squared times h. Volume of our cones, 1/3 pi r squared times h. And then the volume of our spheres, 4/3 pi r cubed. Okay. All right, so now all you're going to do is take those formulas and apply them. So that's what your quick check and your practice and your assessment will be over. Okay. Again, if you have any questions, please reach out. We are here for you. Hopefully this is a little more straightforward because these are just formulas. Take your radius, take your heights, plop them right in, get your answer there. Okay. Just from what we observed from this past week, volume seems a little easier for you guys to grasp. But again, I think this is stuff that you may or may not, but more likely will use later on. I think it's a very practical use. Okay. All right. So that is it. That is all the content that we are covering for this year. So hopefully you're able to get through this. Again, cross that finish line strong, and then you're off to summer. Again, gonna miss you guys. It was a great year, even though it didn't end up the way that we kind of expected things to. Whenever we get back into school, please stop by. Please say hi. We always love seeing old faces around. But yeah. I may or may not release a quick little video next week just to say thank you, just to say hi. But anyways, okay. Good luck with this stuff. Okay. Once you're done, then congrats. You're finished. You're done with geometry. Moving on to Algebra 2. If you have any questions, again, please let us know. If you just want to talk, hop onto our office hours or send us an email. We love just chatting with you guys. Okay? Again, hopefully you guys are safe, staying healthy, getting out and somehow enjoying this weather, this sunny but like 30-degree weather. It's weird, very weird. But again, we miss you dearly. We love you guys. So hopefully you're doing well. And then we will see you when we see you.